Okay, here we go for our second little lesson on proportion. And again, this is very, very directly related to Math 026038 and 052 in terms of specifically being taught in certain sections, as I've indicated there in the slide. And also this lesson in particular relevant for Math 053 because this is literally just equation solving. What we're going to do here. It fits right into chapter 3. It's just a special case of an equation that will come up often and gives you a fast way to solve it when you see it. So first we want to talk about equivalent ratios, which we already have discussed, and then something called the cross product. So last time we did this, so in our last lesson, we reduced ratios. So here's some ratios to reduce. And remember, you do this just like fractions. You just divide both by the same thing, whatever will come out of both of them. So pause the video if you're watching the video and take a couple minutes and try these, or if you're in the class, then I'll give you about a minute to work on reducing those ratios. Okay, so taking a look, actually, and there's a bit more to the instructions than I had said before, isn't there? It actually says to not only reduce them, but actually show that they are equal. All three of those ratios are actually the same ratio. So if we write them as fractions, that's the easy part. 20 over 25, 8 over 10, 10 over 12.5. The first one, the top and bottom divide by 5, so it reduces to 4/5. The second one, the top and bottom divide by 2, so it is also 4/5. And the third one, this one takes a little bit more work. We have some decimals, so remember we write the extra zeros until both the top and bottom have the same number of decimal places. Then we can multiply by 10, which makes the decimals go away, or move one to the right if you want. So becomes 100 over 125. And then reduce both of those. You can go in stages if you want, starting with 5, but if you're quick, you notice that 25 goes into both the top and the bottom. So that's the fastest way to reduce it. And sure enough, 100 divided by 25 is 4. 125 divided by 25 is 5. So all three of those ratios are the same. They are all the ratio 4:5. Now, what we want to do now is discover an interesting property about equivalent ratios. So these four fractions are all equivalent. Those are the four ratios that we set up there. There's the three that we're given, and they all turned out to be equal to 4/5. So all four of these are the same ratio or the same fraction. They're all 4/5. And what we want to discover here is that if we take any pair of these equivalent fractions, so for example, 20/25 is equal to 8/10. I took the second one and the third one, just sort of randomly picked two of them. What we discover is that these are called the cross products in red and blue, and we're going to discover that they are equal. So 20 times 10 in blue, the cross product there is equal to 200, and the red one, 25 times 8, is also equal to 200. And that would work with any pair of these because they are all equivalent. So if we try another one, 4/5 and 10 over 12.5, so this time I take the first one and the last one, wouldn't matter which two I took, the cross products will be equal. So the cross products there, I put in red and blue, and cross products is just a fancy word for multiplying those numbers together. Product, remember, means multiply. So the red one is 5 times 10, which is 50. The blue one is 4 times 12.5, which you can check and find it is also equal to 50. So the cross products of equivalent fractions are equal. That gives us a couple tools to use. First of all, the more powerful one will be the second one we see, but the first one is this actually gives us a way to check if ratios are equal or not, if they are the same ratio. So here we have two ratios, 1.2 to 8 and 5.4 to 36. Now the long way to do this would be to take both of those ratios, get rid of the decimals as we've already learned how to do, reduce the fractions, and see if they turn out to the same reduced fraction or not. That is a lot of work. Instead, let's see, are they equal? That's what the question marks are there for. We don't know if they're equal or not. That's what we're checking. We're going to multiply the cross products, so 8 times 5.4 and 1.2 times 36. And when we do that one there, and again, you got the use of a calculator if you're in Math 052 or beyond, or in 038 as well, once you're done the review units in those courses. So 8 times 5.4 is 43.2. And 1.2 times 36, check it out if you want, it is also equal to 43.2. So yes, because the cross products are equal, these two ratios are actually the same. If we took both of these ratios, turned them into fractions, and did all that reducing we just talked about, getting rid of decimals and everything, we would get to the same reduced fraction. What reduced fraction is that? I have no idea, but we don't need to know to answer this question. Are they the same ratio? All we need to do is check the cross products. So why don't you try this one? Write them as fractions and check the cross products to see if they're equal or not. Give you a minute for that. Let's write those both as fractions. 9 over 1.5 equals 20 over 3.5. Again, I put the question marks there because we don't actually know if they're equal. They might not be the same fraction. Again, the slow way to do it would be to reduce both of those fractions to lowest terms, which would first involve getting rid of the decimals by multiplying by 10 in this case, top and bottom, then reducing the fractions and seeing if they're the same. The fast way is we check the cross products. 1.5 times 20 in red, 9 times 3.5 in blue. The first turns out to be 30, but the second, blue one, turns out to be 31.5. So no, those are not the same ratio. They are not equivalent ratios. What does that mean? It means if you're mixing, maybe you're mixing some kind of gasoline oil mix-up, and 1.2 liters to 8 liters, is that the same as mixing 5.4 liters to 36 liters? Yes, it is, because they're the same ratio. If you're mixing 9 to 1.5, is that the same as mixing 20 to 3.5? No, not quite. Their cross products aren't equal, so they are not the same ratio. Okay, here's the far more important tool. That first one's useful in some situations, but far more useful, and you're going to see this all over the place, is that we can use this special property of cross products to solve equations very, very specifically, just equations that look like this. What do you see about all these equations? I'm going to stress this multiple times over the next few lessons. We have a single fraction on one side and a single fraction on the other side, and an equal sign in between them. If these fractions were being added or subtracted or multiplied or multiplied, or if you had other things being added or subtracted on either sides besides that single fraction, this trick does not work. Some of you might already remember this. This is called cross multiplying. It is one of the most misused thing in all of math. People see it, they learn it, they remember it, but they forget when it works and when it doesn't. It works only when you have a single fraction, equal sign, nothing other than an equal sign, another fraction. So here's what we're going to do. Okay, here. Notice two things. Okay, these could have arisen out of ratio scenarios. So x over 6 equals 18 over 27 could have been the ratios x to 6 and 18 to 27. In other words, maybe you know your ratio of eggs to flour or whatever it is, cement and concrete, it's 18 to 27. And you want to know how much x to use if you have 6 of one of those things. So all three of these equations could have come straight out of ratio scenarios. We'll get to that next lesson. And then secondly, they all have a very specific pattern. This is what I already talked about. They have a single fraction with an equal sign in between them. Cross multiplying using the cross product does not work for any other situation. So let's, there, I stressed that out. A single fraction in blue with an equal sign in between them in red. The only time this pattern can be used to help us solve equations. Okay, what we're going to do is we're going to solve these three ways. We're going to first do it a pretty fast way, and it's probably the one that if you have some vague memories of cross multiplying, it's probably the one you remember. Then we're going to look at a really fast little shortcut that makes these equations really, really quick to solve. And then at the very end, very quickly, and this is mainly for the 053 students, we're going to solve this like the full out, slow, proper is the wrong word, with the equation solving methods we've done in chapter 3 of 053, just to show that it is really the same exact thing as this little shortcut. So I would recommend using the shortcut when you see it applies, but make sure you are clear on when it works and when it does not. Okay, so method one, pretty fast way to do it. We're going to make use of the fact that we know the fractions are equal because we've been told this is an equation. Therefore, we know their cross products are equal. So there we got the two cross products in red and blue. We know that x times 27 must be equal to 6 times 18 because we know that these two fractions are equal. They told us so in the question. This you will remember, some of you, as cross multiplying. You take the top of one times the bottom of the other, and the top of the other times the bottom of the first, like so, and set them equal to each other. It's also called equating the cross products, is another way it's said. And again, I'm going to say it over and over. If this was a plus or a minus or a times sign or a divided sign there, this doesn't work. It only works for an equation. A fraction equals another fraction. Okay, what we've done now is we have created a nice simple equation. X times 27 we would normally write as 27x. 6 times 18 we can figure out as 108. Look at that. This is just a standard one-step equation. We solve for x by dividing both sides by 27 because the 27s cancel, leaving the x all by itself, which was the whole point. And we can work out the right-hand side. And because we have use of our calculators now in this chapter, unless you're in Math 026, in which case apologies when I keep saying that. You have to do this with long division and multiplication, unfortunately. We get our answer, x equals 4. So there is the solution. What over 6 is the same as 18 over 27? Answer, 4 over 6 is the same as 18 over 27. So now that you've seen that method, so we cross multiply, take the cross products, and then just solve the equation that results. Pause the video if you're watching this later, or if you're in class, try these right now. I'll give you a couple of minutes to give these a shot. Okay, so let's take a look. We're doing method 1 here, which is the cross multiplying method. So we take those cross products and we make them equal to each other. So 12 times 35 equals 20 times n, in the blue and the red. So 12 times 35 we can work out to 420. By the way, if you reverse the sides, that's totally fine if you have the 20 times n on the left and the 12 times 35 on the right. 20 times n, we would normally just write 20n. So we end up with a one-step equation, divide both sides by 20, which will make the n become by itself. And 420 divided by 20 is 21. There is our answer. Over for this one, same deal. Take the cross products, make them equal to each other. 12 times t on one side, 44 times 36 on the other. Again, the order of the sides and the order of the numbers doesn't matter as long as you have the right ones together. 12 times t, we're just going to write as 12t. 44 times 36. And you got your calculator, unless you're in 026, so 1,584. Divide both sides by 12, and you get 132. So that is method number 1. Again, you see pretty fast. You just use the cross products, set them equal to each other, and divide by whatever's in front of the variable. Now, what we want to notice here, okay. So method 2 is a really fast little shortcut, which you are more than welcome to use as long as, again, you understand when it applies and when it doesn't. So look at what happened in all 3 of those ones we just did. What did we end up doing in all 3 of them? Look at the first one. I multiplied 6 times 18, then divided by 27. Look back at the question. 6 and 18 are the two, is the cross product pair that doesn't have a variable in it, right? This cross product pair in blue has an x in it, the variable. The red in this case is the one that doesn't have a variable. We took 6 times 18, and then, in all three of them. So in this one, I guess we'll do this first. In this one, we took the 12 times 35. Look down at what we did. We went 12 times 35 first, and then divided by 20. We'll get to that in a second. Look at the third one. We went 44 times 36. In all three, we started by multiplying the cross product pair that had only numbers, no variables. In all three, look at, right, the cross product pair that has numbers is what we multiplied first, and then we divided by the other number. So look at the first one, 6 times 18, the pair that didn't have a variable, and then divide by the other number, 27, and that's how we got our answer. Look at this one here. We started by going 12 times 35, the pair that doesn't have a variable. Then we divided by 20. Look at this one. We started by going 44 times 36. Then we divided by 12. So we can short circuit even the cross-multiplying method by simply find the cross product that has only numbers and multiply them, and then divide by the other numbers. So if we look at a couple new examples here, we have 2 new questions we're going to try. So identify the cross product that doesn't have any variables. So in this case, it's 3.2 times 261, right? Because this cross product has a b. We're going to multiply those two, and then we're going to divide by the other number. That is what we would have gotten if we would have done the first cross-multiplying method. Multiply the pair that is numbers, then divide by the other one. And then that's just something you can take right to your calculator, 3.2 times 261 divided by 16. So I'll give you a minute. Shouldn't take very long. Try this one. Start by identifying the pair that doesn't have a variable, multiply them, and divide by the other number. Okay, so we're going to do the fast method. We look for the pair that has only numbers in it. And y is going to be equal to, by the way, it is important still you write that b equals and y equals. Don't just do the math, right? What do those numbers represent? They are going to be the value of y. So we multiply the pair that has only numbers. Then we take the other number and divide by it. Into your calculator, 26.25 is what y is going to equal. And that is the same number we would get if we cross-multiplied and solved the way we were doing the previous questions. Now, if you don't like this shortcut, if you liked the cross-multiplying and you just felt more comfortable with it, that's totally fine. You don't have to use this shortcut. It's just a quick little way that will solve these equations. Again, only in the situation where you have a single fraction on each side of an equal sign. That is the only time this works. Method 3, if you are not yet in Math 053, I wouldn't even worry about this right now, although you're welcome to follow along if you want. What I want to show you here with Method 3 is not how I would recommend doing this question, but to show you that this actually lines up perfectly with the overall methods we use to solve any equation with fractions in Math 053. So let's take one of these equations we already did. And if you forgot about the cross products and our little shortcut we just learned, and you just looked at this equation, you would say, an equation with fractions. What do I do when I have an equation with fractions? Because it's an equation, can multiply by anything I want and make those fractions go away. So that's what this little note over here says. So I'm going to multiply both sides by 6 because I want that 6 to go away. And I'm going to multiply both sides by 27 because I also want that 27 to go away. And I'm allowed to do this because I'm allowed to do anything I want to an equation as long as I do it to both sides. So if I turn these all into fractions, let's look what happens. We have a bunch of multiplication on the left, so we can do some canceling. Specifically, 6 on the top and 6 on the bottom cancels to 1 over 1. Over on the right side, 27 on the top and bottom cancels to 1 and 1. Looks a bit messy, but let's clean it up. On both the left and the right, notice all the denominators are 1, so we aren't going to have any fractions anymore. On the left, we have 1 times 27 times x, which is 27x. And on the right, we have 6 times 1 times 18, which is 6 times 18. Now, this should look pretty familiar to you because this is the result we got when we cross-multiplied. 27 times x, right? 27x, and 18 times 6. There we go, 6 times 18. So this is, when we cross-multiply, this is actually what we're doing. And I like to actually say that there's no such thing as cross-multiplying. You're really just clearing the fractions out of the equation. Of course, writing it all out like this takes a lot more time. So understanding the shortcut of cross-multiplying is great. But remember, what you're actually doing, this is mainly for Math 053 again, what you're actually doing is clearing the fractions just like we do, just like you are doing with every other equation you run into that has fractions in it. And then, of course, we finish this by dividing both sides by 27. And now look again at this. You see our shortcut right there, right? 6 times 18 divided by 27. The pair with only numbers divided by the other numbers. So again, you see how our Math 053 methods prove to us that this little shortcut we figured out by looking at the pattern actually does work. You take the pair without the variable, multiply them, divide by the other one. So again, this is not how I would recommend doing these equations when you run into them. I just want to show you with method 3 that it really is just equation solving. That's all this little shortcut is. It's a little bypass for equation solving. And we are going to remind you yet again, this only applies in a very specific situation. So we got some examples here. When can you use the shortcuts that we just figured out? A single fraction on each side of an equal sign. So here are some examples of places where you can use the cross product shortcut. One fraction, I think I said a single equation a second ago, I meant fraction. One fraction equals another fraction. One fraction equals another fraction. One fraction equals another fraction. Those are 3 situations where you could use the cross product shortcuts. When can you not use the cross product shortcuts? Any other time. It will not work. So if you are adding 2 fractions, don't take the cross products. They're meaningless. That would have to be an equal sign for the cross products to have any meaning at all. If you're multiplying 2 fractions, the cross products are meaningless. If you're, here we're adding fractions again, but with a variable in there. Don't try to solve for x by doing cross products. That is not an equal sign. The cross products mean nothing. If you have extra fractions, so here instead of having a single fraction equals another fraction, I have a fraction plus a fraction equals another fraction. The cross product doesn't mean anything. Or here I have a fraction equals a whole number minus a fraction. The cross products don't mean anything. So little shortcut that saves a ton of time, but make sure you are clear when you can use it. Only in those situations on the left, not any other situation. Single fraction equal to another single fraction. Cross products save a ton of time. And I don't think I actually solve these, no. So multiply the pair that doesn't have a variable in it and divide by the other number would work on these 3 equations here.